Hello friends, I'll show you how to prove this theorem that the square of any odd positive integer leaves a remainder of 1 when divided by 8. To start, it's important to define an odd positive integer as n equals 2x plus 1 to help exhibit its properties. So the square of any odd positive integer can be expressed as the quantity 2x plus 1 squared, which can be expanded and factored like this. And we need to prove that this expression leaves a remainder of 1 when divided by 8, aka is congruent to 1 mod 8. I'll start the proof with this lemma to make it cleaner. To prove that 4x times the quantity x plus 1 is congruent to 0 mod 8, we notice that x and x plus 1 have different parities. Therefore, one of them has a factor of 2 in it, and note that the number 0 has a factor of 2. And since 4 is a factor in the expression, and we know that there must also be a factor of 2 from either x or x plus 1, the expression is divisible by 8, and the lemma is proven. The lemma is applied and the proof is easily completed by modular addition rule, which allows us to take mod 8 of each of the terms before adding them. And next I want to show another proof using induction instead. And I skipped over the beginning of the proof, which defines the variables and stuff, which would basically be the same as the first part of the previous proof. To start, let's illustrate that the statement holds true for x equals 0, which we do by substituting like this. And now we need to prove that the statement holds true for x plus 1. Specifically, since we need to prove that any odd positive integer squared is congruent to 1 mod 8, consecutive odd numbers should both be congruent to 1 mod 8, which means that they should both be congruent to each other. So we start the inductive step by substituting in x plus 1 for x, which can be simplified to the quantity 2x plus 3 squared, and expanded as 4x squared plus 12x plus 9, and again by the modular addition rule, which allows us to take mod 8 of the terms before we add them. The expression is congruent to 4x squared plus 4x plus 1, and therefore congruent to 2x plus 1 squared, mod 8. So yes, we have proven that the odd positive integer for x plus 1 is congruent to the one for x, and the inductive step is complete. In conjunction with the fact that the statement holds true for x equals 0, the statement is proven for any value of x, because if it holds true for x equals 0 and for x plus 1, then it holds true for x equals 1, and thus x equals 2, and thus x equals 3, etc. And that's how the inductive proof works. It's like a chain reaction. To conclude this video, I want to note that I restricted the domain to positive odd integers to make it simpler, even though the statement holds true for any odd integer, and that x shouldn't have to be restricted to the domain of whole numbers. And actually, the first proof works very well, and doesn't really have to be changed to include negative integers. But I think that the inductive proof has to have 2 inductive steps, so it becomes a bit more complicated, so I don't like it as much for being less general. Okay, thank you guys for watching.